Welcome back. Today, we're taking a serious plunge into something that's not just a buzzword, but a fundamental shift in how technology works, agentic AI. We've got the stack of sources you shared with us, the articles, the research papers, your own notes. And our mission is, well, it's to cut through the noise, grab the most important nuggets, and give you that shortcut to being genuinely well-informed on agentic AI.
Yeah.
We're aiming for those aha moments that stick while keeping it, enjoyable.
This is Sohail Ahmad Podcast, and today we are discussing LLM and agentic AI.
It's definitely a timely topic, and the material you've provided gives a fantastic look at this whole evolution.
Right.
We're seeing AI move beyond just like answering questions or generating content towards systems that can actually do things autonomously in the real world.
Yeah.
It's a significant leap.
Okay, let's jump straight into that leap then. What is agentic AI? I mean, how is it really different from the conversational AI we, interact with daily, like ChatGPT? Our sources make this distinction pretty clear.
Yeah, that's the crucial starting point. Think of a traditional AI model, even a powerful language model, often as a very sophisticated calculator or maybe a writer. It takes input, processes it, and generates an output text, kind, and image.
Okay.
Agentic AI, as the name kind of implies, is designed to have agency. It's not just generating responses. It's built to pursue goals, make decisions, and take actions within an environment with much less human handholding.
So it's not just what it says, but what it actually does.
Exactly. It's about enabling AI to operate independently, to perceive its environment, reason about it, plan, and then execute actions.
Right.
The sources highlight that Gartner actually named agentic AI a top strategic technology trend for 2025.
Wow.
Yeah, which tells you just how much potential they see for it to redefine automation and, transform how businesses operate. It moves beyond rigid rule-based automation into something far more dynamic, adaptable.
The sources really seem to nail down what makes these systems tick. They have a specific kind of DNA, if you will. So what are those core characteristics that define an agentic AI?
Right. The Domo source breaks down these fundamental building blocks pretty well. First, they are goal-oriented. They have a defined objective and actively work towards it, adjusting their approach as needed. The example given is an agent focused on improving customer satisfaction. It doesn't just answer complaints. It might analyze feedback trends, identify root causes, and initiate actions to address those underlying issues.
So it's constantly course-correcting to hit that target. That makes sense.
Precisely. Then there's adaptability. Agentic AI learns from its interactions and the outcomes of its actions, refining its strategy over time.
Like how?
Well, imagine a virtual assistant that learns not just your preferences, but which recommendations actually led to successful outcomes for you and gets better at predicting what you'll like next.
Ah, okay. And the big one, the one that feels like a step into the future.
Yeah.
Autonomy.
Yes, this is central. These systems can operate and make decisions independently without needing a human approval step for every single action.
Really? Like what kind of action?
A network maintenance agent, for instance, might detect a performance degradation, diagnose the cause, and then initiate a fix autonomously. No waiting for someone to click OK.
Which requires environment interaction, right? It has to be able to see and react to changes happening around it.
Correct. It perceives data, system states, or real-world signals. A scheduling agent might detect a flight delay mentioned in an email or a sudden calendar block and automatically suggest rescheduling related meetings. It reacts to the dynamic environment.
And they don't necessarily have to work alone, do they?
No, absolutely not. Multi-agent collaboration is a key feature. Multiple AI agents can work together, maybe specializing in different parts of a complex task.
Like a team.
Exactly, like a digital team. The source mentions a document processing agent collaborating with a compliance agent to ensure a contract review meets all regulatory requirements. They form a digital workflow team.
And finally, they need to actually do things in the real world, or at least in other systems, which means integration with tools.
Exactly. They connect with external systems, databases, APIs, communication platforms. An agent might analyze meeting notes, that's perception and reasoning, decide a follow-up email is needed, that's the action, and then use a mail API, the tool integration, to draft and send that email.
Gotcha.
These characteristics combined are what enable their really dynamic and powerful capabilities.
Okay, so these aren't just theoretical concepts floating around. Why should you, our listener, care about agentic AI right now? What real-world impact are they having or about to have? The sources point to some pretty significant benefits across different fields.
Oh, the advantages are substantial. They dramatically increase efficiency and productivity. Think about automating complex, multi-step tasks that previously required human oversight at each step, managing intricate data pipelines, or orchestrating software updates. It frees up people for higher-level work.
Yeah, I can see that.
Yeah.
And that efficiency must lead to reducing operational costs, right? Fewer manual hours, fewer errors.
Absolutely. Fewer errors, more consistent execution. They also can significantly improve customer satisfaction. Agentic systems can handle inquiries and issues much faster, maybe providing highly personalized support 24/7.
Makes sense. And as tasks or data volumes grow, these systems support scalability.
That's a big one. They can take on increasing workloads without needing a linear increase in human resources. And a major benefit is enhanced decision-making. Agentic AI can analyze vast amounts of real-time data, identifying patterns, risks, opportunities, stuff humans just couldn't process at that speed or scale.
And by taking over some tasks, they help ensure accuracy and consistency, minimizing that potential for human error in critical processes.
Exactly. The benefits really touch almost every part of an organization.
So how does all this work? Under the hood, how do you actually give an AI goal orientation, autonomy, the ability to interact? Our sources give us a bit of a look at the architecture and the underlying process.
Yeah, the demo source talks about the agentic architecture as the sort of framework that guides this behavior. It's designed to allow for that independence and adaptation, connecting various systems and data sources. Key elements here are like internal capabilities, intentionality, the ability to form and hold on to goals. Then self-reactiveness, so monitoring its own progress and performance. And self-reflection, which is learning from past actions and outcomes to improve future behavior.
Okay, like internal feedback loops and planning.
Kind of, yeah. Think of it like the AI's capacity for planning and self-evaluation.
So it's not just reacting, it has a sense of purpose and can evaluate itself.
Exactly. And this architecture supports a typical multi-step process these agents follow. It often starts with perception.
Okay.
The agent gathers information from its environment, reading documents, monitoring system logs, pulling data from databases or APIs. It's taking in the current state of the world relevant to its task.
Like seeing or hearing, but, with data streams.
Right. Then comes reasoning. This perceived data is often processed by a large language model, the LLM, which acts as the agent's brain.
The brain, okay.
The LLM interprets the information, identifies patterns, applies logic, and forms a plan or decision about what to do next.
Okay, so it thinks about what it perceived. What's next?
Step 3 is action. Based on its reasoning and plan, the agent takes action. This involves interacting with the environment or other systems, usually through APIs, updating a database, sending a message, controlling a device, running some code. It executes its decision.
Right, it does something.
And the crucial final step is learning. The agent observes the outcome of its actions and incorporates feedback, continuously refining its reasoning and planning processes. This learning loop is absolutely key to its adaptability.
That makes sense. Perceive, reason, act, learn, repeat.
Pretty much. That sequential process, often iterating multiple times to complete a complex task, is the foundation. And the RSIG source introduces this idea of agentic multi-agent systems, or AMAS. Yeah, where you have multiple of these LLM-powered agents working together. The paper highlights the modular design of these systems, breaking down the overall task into parts handled by different agents, or maybe layers like perception, reasoning, and action. It allows for really complex, coordinated behavior.
Okay, so this isn't just theory or lab stuff. These systems are already showing up and transforming industries. Our sources give us some fantastic real-world examples.
Oh, yeah. We see familiar examples like self-driving cars, right? Constantly perceiving the road, planning maneuvers, acting autonomously.
Sure.
Or personalized assistants that learn your routine and proactively manage tasks. Dynamic pricing algorithms in e-commerce, adjusting based on real-time demand. Delivery drones figuring out routes.
Right, those are becoming more common. But beyond those, healthcare seems like a really big area.
Absolutely. The UTM News Hub source details agentic AI assisting medical professionals analyzing patient data, scans, research to aid diagnosis, suggest treatment plans. They can function almost like a team of specialists, which would be incredibly valuable in remote or underserved areas. Think of an agent analyzing a complex medical history and spotting something a human might miss, or assisting in robotic surgery with extra layers of precision.
That has really profound implications. What about education?
Agentic AI is starting to help personalize learning there, too. Virtual tutors can assess a student's understanding, identify weak spots, and create customized study paths that adapt as the student progresses.
Tailored learning.
Exactly. And they can also automate administrative tasks like scheduling and maybe some basic grading, freeing up educators for more direct teaching.
Speeding up discovery and scientific research must be another big one, surely.
It is. Agentic systems can automate vast numbers of virtual experiments, analyze enormous data sets, generate hypotheses much faster than traditional methods. This is accelerating things like drug discovery, screening thousands of potential candidates, or designing new materials with specific properties. It's huge.
And keeping us safe in cybersecurity, that seems like a natural fit.
Yes, very much so. Agentic AI can autonomously monitor network traffic, identify suspicious activity, hunt for vulnerabilities, and even initiate containment or remediation steps against cyber threats in real time. That significantly enhances defense capabilities.
So finance with automated trading bots, retail with personalized shopping, it really does seem to be everywhere.
It's truly a cross-industry phenomenon. The potential applications are incredibly broad.
Okay, if you're listening to this thinking, wow, this is powerful, maybe my organization could use this, what's actually involved in building something with this technology?
Yeah.
Our sources offer some guidance on moving from just an idea to a real product.
Yeah, and the O'Reilly source makes a really critical point here. Agentic AI, or the LLMs themselves, they're the technology you build with. They're not the product itself.
Right, like ChatGPT is an application using an LLM.
Exactly. So the biggest challenge, and really the key to success, is starting with a clear, strong use case and having a product mindset. You're not just building tech, you're building a solution to a real problem powered by this tech.
Don't just build a fancy AI for its own sake. Build something genuinely useful.
Precisely. The source then talks about the toolkit needed. One crucial part is model selection. Choosing the right LLM, considering if it's proprietary or open source, its performance characteristics like latency and, of course, cost.
Any tips there?
They suggest maybe starting with a powerful general-purpose model to explore the possibilities, then perhaps optimizing with smaller, more specialized ones later once you know what you need.
Makes sense. Another crucial piece seems to be prompt engineering, which we've touched on before, but it sounds like it's even more critical here for agents.
Yes, absolutely. For agents, the prompt isn't just asking a single question. It's essentially programming the agent's behavior, its goals, how it should use tools. It's about being incredibly explicit.
How so?
Providing clear examples, that's few-shot prompting, and carefully controlling the output format or tone. And collaborating with subject matter experts is vital if you're working in complex, niche domains. It's a highly iterative, experimental process. Documentation is key, too.
Okay. And underpinning everything, as always, is the role of data.
Data is non-negotiable. It's essential for evaluation testing how well your agent actually works, using quantitative metrics, but also getting real human feedback. And critically for enterprise applications, it's key for retrieval augmentation, or RAG.
RAG. We hear that acronym a lot. It sounds like a way to keep the AI grounded in reality, stop it from making things up.
That's exactly what it's for. The O'Reilly source explains how LLMs can sometimes hallucinate or rely on outdated knowledge from their training. RAG is a powerful solution.
So how does it work? Simply.
Before the LLM generates an answer or plans an action, a retriever component searches your specific, trusted, up-to-date data sources, your internal documents, databases, knowledge base, and finds the relevant information for the current query or task.
Okay.
The LLM is then given this retrieved information and instructed to base its response or plan only on that verified data.
So the AI isn't just relying on its massive general training data, it's referencing your specific facts for that specific task.
Precisely. The O'Reilly diagram concept shows this flow clearly. Query comes in. Retriever finds relevant info in your documents. That info gets added to the prompt sent to the LLM, and LLM answers based only on that provided info.
Which means the quality of your own data is paramount. Garbage in, garbage out, amplified.
Exactly. The quality of your data directly determines the quality of the ARG output. So data curation, keeping it clean, accurate, well-annotated, having clear guidelines becomes absolutely vital.
Now, bringing these different pieces together, the model, the prompts, the data, RA often involves something the sources call composability. What's that about?
Composability basically means building your AI application in modular parts, like building blocks. Our RAG itself is a form of composability. You've separated the retrieval part from the generation part.
And the benefit of that modularity.
Flexibility. You can update or swap out components independently as the technology improves. Maybe a better retriever comes along, you swap it in. And it makes debugging much easier because you can test each piece separately to find errors.
And agents build on this modular idea.
Yes, agents really take composability further, creating more complex pipelines or workflows. They leverage the LLM's reasoning capability to orchestrate multi-step processes, decide which tools to use at each step, like calling a specific API or searching a particular database in managed state using memory.
Memory, so they can remember past interactions.
Yes, to maintain context across multiple steps or over longer conversations. The O'Reilly agent architecture diagram concept illustrates the LLM interacting with various tools and its memory to execute a coherent plan over time.
Now, with all this increasing power and autonomy comes, well, significant risks. As agentic AI gets more capable, new challenges pop up, particularly around trust, risk, and security. Our sources really zero in on this area, sometimes called TRISM.
It's an absolutely critical focus because the complexity and autonomy of these systems, especially when you have multiple agents interacting, can create decisions that are hard to understand, kind of opaque, and introduce new vulnerabilities.
Like what?
Well, the ARC source mentions this. If not handled carefully, there's a real risk of inadvertently mishandling sensitive data or, falling out of compliance with regulations.
The Immersive Labs source details some specific concerns. One they mention is blind trust.
Yeah, this is a big one. Just assuming that because an AI generated something or took an action, it must be correct or safe.
Right.
If an agent suggests, say, a software fix, just applying it without verification could be disastrous, especially if the agent's training data happen to include vulnerable code patterns it learned from.
Yikes. There's also the huge issue of data handling and compliance.
Definitely. If an agent can access sensitive databases or communicate externally without really strict controls, the risk of data leaks or breaching regulations like GDPR is significant. Ensuring agents operate within clearly defined, secure boundaries is paramount.
And this autonomy raises tough questions about ethical and reputational risks, doesn't it?
Absolutely. When autonomous agents make decisions, especially in high-stakes scenarios, think finance or healthcare, and something goes wrong, figuring out accountability and liability gets really complex. The sources imply that organizations deploying the AI, not the AI itself, will likely bear that responsibility.
We also see prompt injection mentioned again. That's still a threat here.
Oh yes, even within multi-agent systems. Inputs to an agent, whether they come from a user or maybe even another agent, need careful sanitization and validation. You have to prevent malicious instructions from hijacking the agent's behavior. Limiting what an agent is allowed to do its permissions helps mitigate this.
For developers using AI to help write code, the sources mention business logic flaws.
Right. AI can generate code quickly, but that code might contain subtle, complex logical errors that are incredibly hard to detect during testing and debugging. These could lead to significant system failures down the line.
And the R source points out risks specific to having teams of agents working together, like agent collusion or mode collapse. What's that?
It's basically when agents within a collaborative system start reinforcing each other's incorrect assumptions or errors. It's like AI groupthink. They can all converge on a flawed outcome because there's no external check or diversity of thought to catch the mistake. The paper mentions a case study where errors in a shared planning component propagated across the whole team unchecked.
That's worrying. And the general challenge of emergent behavior, just unpredictable stuff happening.
Exactly. Complex, unpredictable behavior that arises simply from the interactions of multiple autonomous components. It can be very difficult to anticipate or test for all possibilities beforehand.
Plus the ongoing challenge of adversarial robustness. People actively trying to break it.
Always. Despite safeguards, intelligent attackers are constantly finding new ways to manipulate AI inputs, like prompt injection, or even the training data itself, data poisoning, to cause desired malfunctions, including in agentic systems. Defenses require continuous evolution.
So how do we manage all this?
Well, this is why frameworks like TRISM trust, risk, and security management are emerging. They aim to provide a structured approach. It includes layers like explainability, trying to understand why an agent made a certain decision, which is really hard in complex multi-agent systems, but crucial for traceability.
Right.
Also, model operations, that's continuous monitoring and logging of agent activities, application security building defenses against those attacks we mentioned, and model privacy protecting the data the agent handles. This is all aligning with upcoming regulations too, like the EU AI Act or standards like ISO 42001.
Okay, so despite the challenges, looking ahead, what's the forecast for agentic AI? The sources paint a picture of, well, explosive growth and transformation.
They certainly do. The market for agentic AI was valued at over $5 billion in 2024, but it's projected to exceed $47 billion soon.
Wow, $47 billion.
Yeah, with annual growth rates around 44%. And Gartner predicts that by 2028, a significant chunk, maybe 15% of daily work decisions will be made autonomously by agentic AI. That's a huge jump from almost none today.
That's not just growth. That's a fundamental shift in how work gets done.
It really is. The sources highlight key trends we can expect for 2025 and beyond. We'll see a major change in the workplace, with agents handling more routine and even complex execution tasks, allowing humans to focus more on strategy, creativity, complex problem solving.
And AI becoming more like collaborative team members, not just tools.
Exactly. Participating in meetings, proactively suggesting strategies based on real-time data analysis, functioning as integrated partners rather than just, software you use.
With that increased capability and responsibility will surely come stronger AI regulations.
Definitely. Expect more focus on governance, compliance, the need for explainability and security as regulators work to keep pace with the technology's capabilities and, frankly, its risks.
Leading, hopefully, to smarter decision-making from the AI itself.
That's the goal. As the underlying models improve, agents should get better at reasoning through nuanced situations, assessing multiple factors, maybe even incorporating ethical considerations into their decision-making processes more effectively.
The analytics video source points to increased specialization across different industries as well.
Yes, agents becoming highly tuned for specific domains like finance, healthcare, or supply chain management. We'll also likely see a shift towards more proactive AI agents anticipating needs and taking autonomous action without always waiting for an explicit prompt.
And incorporating more than just text data.
Absolutely. Greater multimodal capabilities agents that can seamlessly process and integrate information from text, voice, images, maybe even video for much richer interactions and understanding.
And finally, the idea of bridging different areas, creating interconnected ecosystems.
Yeah, imagine agentic systems in healthcare interacting smoothly with finance systems for insurance or billing, or supply chain agents coordinating directly with manufacturing agents. We'll see these systems talking to each other more and more, creating more integrated workflows across industries.
And as these systems get more sophisticated, the sources remind us that evaluating them isn't just about did it complete the task, but also things like trustworthiness, explainability, user satisfaction, and how effectively different agents coordinate within a system. That seems crucial.
It is.
Yeah.
And getting from that initial idea or a promising pilot project to a robust, production-ready agentic system requires building with that clear business case in mind from the very start, really focusing on scalability and implementing strong MLOps practices for continuous monitoring and improvement once they're deployed.
And as we've hammered home, responsible development, addressing the ethical and security concerns proactively, and ensuring compliance are absolutely non-negotiable steps throughout that entire process.
That focus on building responsibly is paramount as these systems gain more autonomy. You just can't bolt it on at the end.
Wow. Okay. That was a genuinely deep dive. We really unpacked agentic AI, what it is, what makes it fundamentally different, its core characteristics, the transformative benefits it promises, how these complex systems work under the hood, the practicalities of building them with the right toolkit, the absolute critical challenges around trust, risk, and security, and a look into the future with its rapid growth and evolving capabilities.
Phew. We've definitely seen how this technology is set to move far beyond simple automation, creating powerful, collaborative systems capable of autonomous action, and why understanding the nuances of their design, deployment, and governance is so key to harnessing their potential safely and effectively.
Our mission was to use your sources to give you that shortcut, to get you quickly and hopefully enjoyably informed on agentic AI, and I think we've done that, uncovering some really fascinating insights along the way.
Absolutely. And as agentic AI continues its rapid ascent, taking on increasingly complex tasks and making more autonomous decisions, here is maybe a thought for you to consider based on everything we've explored today.
Okay, lay it on us.
How will the relationship between humans and these advanced AI agents need to fundamentally evolve, especially in critical decision-making areas like healthcare or finance, to ensure collaboration is not just efficient, but also safe, transparent, and truly aligned with human priorities and values? How do we build that trust and maintain oversight effectively?
That's a big question. How do we evolve that relationship? Something to definitely mull over. Thanks for bringing us this fascinating topic and your sources for this deep dive. Really appreciate it.
My pleasure. It's an important conversation to have.
It certainly is. All right. Thanks, everyone, for joining us. We look forward to the next one.